Hello, hello, hello. Welcome, Ed.
Hello. Hey.
How's it going?
Pretty good, David.
Awesome. So we are here today. We are going to take a look at a couple of technologies that I'm a big fan of, and I think you started playing with recently too, which is SaltStack on packet hosts with a little bit of Pulumi thrown in. So we work together at Packet Hosts, right? And I think we've kind of, I think I mentioned SaltStack a few times and piqued your curiosity. Do you want to just give us a little bit of background there?
Just a second. I got confused there for a moment.
Okay, no problem.
Can you rewind 15 seconds? I had another audio stream accidentally playing. I was hearing the broadcast of our thing. It's like, wait a second, I've heard that before.
Yeah, no worries. So I was just telling the people that are tuning in, we work together, Packet Host. I've been there about 6 weeks, I think, maybe a little bit longer now. During that time, I've been yapping on about SaltStack once or twice. I think your interest got a little bit piqued and you started to take a look at that yourself. So.
Yeah, so I'm using SaltStack myself to manage what I call a menagerie of little home systems, Raspberry Pis and Jets and Nanos and the like. I've run it once, sort of in production. I want to say sort of in production because we were using it, but it was not driving most of things. And I'm just curious as to how especially it can be useful to paper over some of the differences when you're managing a network of heterogeneous systems. The machines I have in my home lab, some run Ubuntu, some run Debian, Ubuntu 18, Ubuntu 20. I spun up a FreeBSD machine. I plan to put a CentOS machine in there somewhere. So just like the mix of systems that you might each want to individually experiment on, but yet you will still want to run the whole mess as if it was one unit and not a whole bunch of individual machines.
Excellent. I'm sure we can do that. So let me share my screen. Let's just get started. Yeah. I think the best thing to do is just kind of start with where we're starting from, right? So I did do a small session on provisioning packet servers with Pulumi and bootstrapping the cluster with SaltStack and kind of just left it there. And the rest of it was left to the reader's imagination. And I want to close that gap today. So what I've prepared in advance is really just creating this empty packet project. We have no servers currently available. However, we do have the codes from last time, which I will quickly run you through. We'll get that kicked off and deploying, and then we'll talk about how we can leverage some of Salt's really cool and unique features to manage all those servers with a single API, which I think is really important, and kind of from what you've said there. So, with regards to the Pulumi code, I'm using TypeScript. One of the really cool things about Pulumi is you get to use the language of your choice as long as it's supported. It supports TypeScript, Go. There's some .NET support, Python support, and maybe one or two others. For me, I like TypeScript, so we're going to go with that. And what this code does is it will create a salt master and a single minion. I think one of the first things we should do is just change this setup to be more diverse and reflective of what you had in your head with regards to operating system and even hardware differences. So let's see what we have. This is the code that spins up the salt master. And you can see from this block of code here that it is provisioning a new device on packet, an Amsterdam 1, a C2 medium with Debian 9. So I think what we do for our minions is try to have a nice variety that did not reflect this. So if we come into, I think we'll need to change our minion code a little bit, but that's all right. I don't mind a bit of live coding. So our minion code currently hard codes the same values. So if we assume that we want to change this, do you think changing the plan in the operating system and doing a few varieties of those is enough to kind of?
Yeah, it sort of gives the flavor for it.
Awesome.
I would suggest. Well, let's see. So in my experiment, sort of back up a little bit. In my experiments, there are differences between Debian and Ubuntu in terms of package management. They're not usually great until you run into them unexpectedly. The real challenges get to be as you get further from those two systems. Package names changes, tooling changes a little bit. So, what plan should we pick?
Yeah, let's start with that then. So let's.
Yeah.
I mean, I should know these off the top of my head, but I must say I'm really bad at that. So let's just use the UI where possible. I think we do get autocomplete with Pulumi. The reason I'm not going to use it right now is just because it doesn't currently check the availability. So I can pick them, but I have had issues where I say I want an M1 extra large, and it's just not been available. So it's nice to come in here and just confirm in real time what we've got. So how about a C1 large ARM?
Sure.
I think we tick a couple of boxes there, don't we?
Yep.
And operating system on ARM, we've got.
Pick a Ubuntu, I think, because it'll provision fast.
Okay. I guess Ubuntu 1804. Now, we're going to add another minion, so I'm just going to make these configurable as well. So we'll pass in a plan and a operating system. And then we'll reference these down here. And that just means that we can just make it a bit easier for us to spin up more. Assuming I learn how to type. Okay. So if I pop back to our index, when we create this here, we need to then specify plans, C1 large, and operating systems. And we were going to go with Ubuntu 1804. And then we can copy and paste this, and we can create 2 more machines. So I'll call this minion 1, 2, and 3. And it's formatted a bit nicer for me. Cool. How about we spin up let's get something. So the C1 ARM has 1 SSD, 2 gigabit disks, ThunderX processor.
Yep.
So, and what was our first device?
First one was a C1 large ARM with Ubuntu. You want to do a C1 small?
So our master, yeah, it's an AMD. So why don't we grab the Xeon here for something just a bit different? S1 large x86.
Yep, that's a storage server, so that's got a whole bunch of storage on it.
And what was the other suggestion you made?
A C1 small.
Got it.
That's a good workhorse machine.
All right, so let's see. Storage machine. Let's run. Let's look at all the operating systems. How brave are we feeling?
FreeBSD, is that going to work on FreeBSD? I don't know.
So as soon as I seen that, I knew you were going to mention it. So if we take a look at the minion user data, we will need to just tweak this a little bit so that it works on FreeBSD.
Right.
As long as we know how to install Salt on FreeBSD. In fact, you know what? We can make this. Salt provides something called Salt Bootstrap.
Right. A very helpful script that takes care of the whole install process.
Yeah, so we don't necessarily need to hard code it the way I have to use package managers. So as long as we've got machines with curl on it, I don't really foresee any problem with just dropping in the code like this.
Yeah, except I think on FreeBSD the tool is not curl. There's something called fetch there. Maybe that's in the advanced challenge.
The advanced challenge. Well, I'm going to add the FreeBSD box, but we'll maybe add another one just in case. So we've got.
Yeah,
in fact, we've got 3. I think we'll be okay. Let's do it. I'm brave. Okay, so user data. We'll use this. If FreeBSD fails, we can SSH onto that machine, quickly run salt bootstrap manually, and fix the setup later. All right. Which means we need to pop back to here. So let's make minion 2. In fact, are you happy with the storage one being FreeBSD? Do you foresee any problems there?
The only thing I can think of is that it might take longer to boot. So it might end up being the last one that comes up.
Yeah, that's okay. We'll deal with that then. Okay, so the last machine is a C1 small. So let's just make sure we get an accurate.
Yeah, if you could put try, I know you had Ubuntu 18 for one of them. I didn't see Ubuntu 20 in the dropdown, so I don't know if that's a matter of provider not knowing about it yet.
Yeah, I think the provider just isn't up to date with the latest versions. I think we've found another session we can do where we update the provider.
Yeah.
How about we do CentOS then? That gives us a good mix of operating systems.
Yeah.
So CentOS 7. Okay. So we can run this now. Hopefully we don't run into any problems. Do I set the project ID anywhere?
Yes, you did.
Do I?
Platform.project ID.
Aha, cool. So, yep, I think there's just a little bit of configuration that I need then. Yeah, so we just need to set the project name and organization ID. Okay, so config set project name. I called it Rawkode SaltStack. And organization ID. And I can grab this from here. All right, let's see how happy it is. So it's going to try and attempt, it's going to create a project. That's okay. Let's just give it a unique name then. We'll say no. I forgot that it creates a project.
Oh, it creates from scratch.
Yep. Okay, so it's going to create a project. It's going to create a master device and 3 minion devices. And assuming my API token is incorrect, we're good. The project is now created. So if I refresh this page, when the first thing gets created, there's always this like sigh of relief because I know like if anything goes wrong, it's fixable from this point forward. So
yeah,
there's our project. And we can see the master is on its way. So this will take, I guess, 5 minutes. Yeah. Well, hopefully less than 5 minutes, potentially up to 5 minutes. But we can take a look at some of the other stuff that's going on in this repository, just to get an understanding of what's going on. So this platform object is just something that I do, I think, in every Pulumi project. And it's really just a wrapper around the configuration to make things a little bit easier. And it also applies types to the configuration too. So, just by doing this, I can say, hey, this, and then I pass it around everywhere I go. So you can see here, we run get platform. we grab the name, and then we pass platform into all of these functions, which are used as helpers to then provision new infrastructure. If we take a look at the Salt Master, which we've already kind of looked at, it just creates a device. Something that's really cool about Pulumi is that I'm using npm to pull in dependencies that also make my life a bit easier. So you can see, I'm not sure if you're familiar with Mustache, but it's a templating language for Node.
Yeah.
And it just means that I can keep my user data provisioning script in its own file with its own name and its own syntax highlighting. And where needed, I can interpolate using Mustache. You can just see that I'm dropping in some Python code as well, which is available here. So I like this setup. It works really well. Nice. Now let's talk about this Python code then. So one of the really cool concepts within SaltStack is it has something called a grain. And a grain is a piece of metadata or information or a key value pair that is specific to one of the minions. And Packet also has this metadata endpoint here, which can be called from any of our devices, and it returns the metadata about the hardware and the software and other bits and pieces too, and the back-endy stuff. And SaltStack doesn't support this out of the box, but because Salt is in Python and it's relatively easy to extend, like under 18 lines of Python, I was able to just consume that API and then make these grains available. Now, the use case might not be completely apparent yet, but once we get onto one of these machines, we can actually realize that we can use the facility, the plan, the class, the IQN, and ID as targets when we're trying to query our minions. And this is the tags as well, which is cool.
So it's worthwhile thinking through. Salt has some terminology that's unique to Salt. Grains are unique to the machine, but there's also pillars. I admit to being a little bit flummoxed sometimes to figuring out exactly which is which. Like some things are, you can query a node based on, for instance, its operating system, right?
Yeah, for sure.
You can query a node or act on a node based on data that's stored on that node or data that's stored on the master.
Yep. So I'll dive into that a little bit then. And if anything is unclear, just prod me. So
yeah.
You're right. The grains are specific to each of the minions. So that's a device in our case here. So a server is going to, the grains will expose the operating system, the processors, the number of disks, the types of disks, the kernel version, all of that stuff, all the stuff that is used to describe that minion. The pillars, on the other hand, are usually either hard-coded or provided to the master or come from a third-party data source. So there's actually many different sources for pillar data. You can use Postgres, you can use MongoDB, you can use managed cloud services like S3 or RDS, and there's so many. In fact, let's just pull this up. Salt pillars. If we go to the documentation here, I think this link. And click on pillar modules. So these are all of the modules which support exposing pillar data to the master. So you can see we've got Azure Blob Storage. You can execute arbitrary commands as long as they output JSON or YAML. Then Salt will parse that and make that available. Cobbler is for bare metal provisioning and some other provision management stuff, which is really cool. Console can be used. What else? etcd, straight up file stuff. You can consume pillar information from a Git repository, which I quite like doing as well as the command stuff. You can use HTTP APIs to pull in anything that's JSON or YAML as well. There's Mongo, MySQL. So, there is lots of different sources. And the use case for most of these is generally for data that is considered almost secret, or at least it can be secretive. So it's not going to be provisioned through the standard means like we're doing now. Like if you can imagine, well, this is all in Git. And in theory, I could make this all public. There's nothing secret in this repository. And the
Right.
pillars would be that place where secret information could come from. So whether I want to have CA bundles or certificate authorities or private keys or just plain old secrets, I could have them in Vault and then have Salt speak to Vault to pull that information in for pillar data. That makes sense?
That makes sense.
Good. It's been a while since I've tried to explain grains and pillars, so hopefully we're good. Now, the user data is only slightly different for the master and the minion setup here. So the good thing I spun that up with Debian because I never changed it. But it's installing the Salt master and the minion. So that's another kind of cool thing about Salt is that the Salt master can also run its own minion, and it can have this sort of self-referential bootstrap process or provisioning, or high state as Salt would call it. We need to grab the local IP. We use this just to bind the interface that Salt listens on. So we're trying to keep this secure. All of our packet devices, and I think you'll need to correct me here. I think they all by default launch with a public IPv4, a private IPv4, and an IPv6 address.
That's correct. Yeah.
So we don't want our Salt master listening on our public IPv4 address because, unfortunately, the remote code execution is a thing. So we want to trust only our private network. What else do? We just tell it where the master is. So this is us configuring the Salt master as its own minion. So we just have to drop in that the master is available on the local device IP address. And then we provision the packet metadata. So like extending Salt could not be easier. You literally just have to drop in a Python script into the right location on the device, and magically it's available to us to call. So, really simple.
Nice.
And then our minion one is easy. I mean, I've just copied 2 lines from something off of GitHub and dropped it into this. What could go wrong?
What could possibly go wrong? So the cluster that I have adds another complication to things because looks like something came up. Because the devices are not all in the same packet network. So I in my configuration, I do not have the ability to just use the packet private net 10 address. So what I did for that was took advantage of the fact that I'm using Tailscale, which is a VPN network. And I do the same kind of binding, except I bind it to the Tailscale address instead of the public address. Nice. And that way I have bootstrapping is harder because you have to bootstrap Tailscale first before you boot SaltStack, but you have this sort of same idea of a private management address to connect things through.
Very cool. I like it. I've never really considered using Tailscale to kind of provide a backbone for disparate sources or networks and keeping them all in the same Salt network, but that's a really cool concept.
It's been going reasonably well. I don't know how I would debug it all if I didn't have out-of-band access to everything. Right. I've got out-of-band access to the packet machines. I've got a little breakout box that I can plug into Pies if I need to. Like most of the stuff here could be scrapped and restarted if I had to. But just having a management channel is really handy.
Yeah, for sure. I can see that. All right, so let's understand. You're right there. You said something has come up. So another thing, Terraform and Pulumi both do this, but they actually build a graph of dependencies when they parse all of the resources that the automation is supposed to create. Because our minions have a dependency on the master, i.e. they need to know the IP address. That was created first in isolation. And if we pop back over here, yeah, we'll see those other machines coming up. And then these were all created in parallel because all of those dependencies are satisfied, which was just the master. Our minion 3 was the fastest. Our CentOS 7 box was pretty quick at coming up. We're now just waiting on our FreeBSD and our Ubuntu machine. But there's nothing stopping us going and kicking the tires on this master and getting started.
Yep.
Let's pop open a new tab. And let's do root. Yes, please. Oh, YubiKey. There we go. Okay, so we are now on master 1. So let's just confirm that everything worked as expected.
Yep.
Yeah, I have a master running and the minion is running. There are multiple processes, but that's not important right now. So how can we confirm our configuration? Well, first we're going to go to /etc/salt. We will just confirm our minion was configured as we expected. You can see our master IP address was set. And we also did some master configuration where we bound the internal IP address. So I'm very confident at this stage that the provisioning was successful, which means we can begin to interact with Salt. Now, no minions have matched a target. That's expected. That wasn't me just making a mistake. So we do have our Salt Master running. We do have a Salt Minion running. Our Salt Minion knows how to speak to the Salt Master, but we have not approved the keys. Okay. Now, what Salt does when you install it, it will generate some certificates which are used to authenticate with the master machine. So our minion generates their certificate, it sends its key to the master. We have to actually explicitly approve that. Now, there are steps to automate it, not something that I think we'll be able to cover in this session. But for now, what we can do is tell it to accept master 1, like so. And then if we run salt key one more time, we now have our accepted key. Now, I do have one small concern right now, is that I expected to see minion 3 listed here because
the CentOS machine.
Yeah. So I'm assuming the salt bootstrap on this machine potentially failed.
Right.
So shall we go quickly take a look at that?
Yep. So let's take a look and see what's going on there.
Okay. So yes, press my key. All right. So salt is installed because the directory exists. My configuration, that's the default minion conf. It doesn't generate keys. Right, let's see what's going. And it's not running.
It's not running.
But it looks like the command is available.
No longer supports Python 2. Yes.
Okay, so that means DNF install. I mean, let's try the naive approach. Oh, is it not DNF? That must be yum on CentOS.
Yum.
So I'm just going to run this manually. Run the. Can I remove? Oh. No uninstall. Remove Python 2.
This is CentOS 7.
Yeah, it's quite an older version, isn't it?
Yeah. So I wonder if the thing to do is to uninstall Salt Minion entirely and then reinstall it from the Bootstrap script.
I don't know what the package is called. Oh, so I might have installed it through pip uninstall. And maybe that's a problem because it might not have been using pip 3. I might have just used pip, which is probably pip 2. Pip there. Yeah, 2.7. So if we do have pip uninstall salt minion, or it might just be salt. There we go. pip3 install. Oh, that should get us running.
Yeah. Python.
I would have expected Salt Bootstrap to handle that, to be honest.
Yeah, I would have expected it to.
What didn't work there? I've got access to Salt call pip install Salt. Yeah. Nope. That's weird. But I have all the other commands.
Why is Salt Minion not working?
Good question. Which Salt Minion? User. Oh wait. Salt SSH. Yeah. Okay. I mean, that looks all right. Python.
It's Python 3. Is Python 3 installed?
Yeah. Okay, it's working now if I do that very explicitly.
That's weird.
Let's just quickly, what happens if I do user bin? So that's the wrong path. Let's log out.
It's the wrong path, yeah.
When in doubt, log out. Hey. Okay, so.
Okay.
Now.
There's a path issue.
I am going to believe if we take a look at our cloud init log, that our provisioning step, because we never installed, let's just pull that up. I'm assuming this failed, which means we never created our config. So let's just do that manually as well. We'll get there. So minion.d, we'll copy this from another machine. Oh, that's...
You get the wrong one. Or...
it's all right. We'll grab the IP from here. So
yeah.
And let's pop over here, go to our Salt configuration. We want to go to minion.d and we want to do master.conf. And if we run systemd start Salt, will that work? Daemon reload. So it's using the wrong path too.
It's using the wrong path too.
That must just be something weird with the way it installed. All right, let's modify the unit file. I'm committed to fixing it now. I feel like I need to get it. Systemd. How do you get the? Is it describe? No. Info? I can't remember.
I can't remember either.
Describe a unit file. Wait, you can do status, and it will show me where the unit file is.
Cannot be found.
Here. What did I do? There we go. Well, them user local.
Oh.
Let's try a daemon reload. Start Salt minion.
Hey, no errors.
Right. Okay.
Wow. Wow. So I think the moral of that story is that the older the version of the operating system you are running, the more likely it is you will have to intervene.
Oh yeah, for sure. And I didn't realize. Sorry, I wasn't. We had someone drop in the comments there and try to help us out, Bradley.
Hey, Bradley.
Says we could do cat salt. I've never done that before. Ah, that is so cool. Thank you. Awesome tip.
Yeah.
Right. Okay. So that's running. So let's run our salt key. And we have minion 3.
It's there.
But we don't have minions 1 and 2. So I think we're going to be fixing those as well. Hopefully it's the same problem and we can fix it relatively quickly. But for now, let's just accept minion 3. Okay. We will fix those other 2 nodes, but let's try and cover a couple of basics of salt then. So the first salt command I think anyone should run is test.ping. And let's just cover the 2 syntax that you'll see online for this command. This tripped me up when I was first learning this all, and it's so simple, but I'll cover it anyway, is that the star gets expanded by your shell, by bash or z shell or fish. So you don't need to just wrap it in single quotes or escape it. And that's why you can't just do star. Yeah. It's always bugged me. Always bugged me. But the test.ping is the simplest command. All it does is try to establish if the salt minions are online. And you can see that the 2 that we've managed to successfully accept and provision, they are online. So now what can we do? How about some executing remote commands? That sound like fun?
Sure.
What would you like to know about our machines, or what commands do you want me to run?
One of the things that I will normally do when logging into a machine will be run something like uptime to see how long it's been up, or who to see who else is on the system, if there is anyone else in the system.
Yeah, great commands. I use those commands all the time as well. So let's run who. We can see me fixing minion 3. And we can run uptime. And we can see both our machines have been alive for less than 20 minutes, which makes sense.
Yep.
Now, right now, we've been targeting every machine. So why don't we kind of cover the different targeting options that are available? So let's try targeting by name. Simple.
Yep.
And
you can use star in that configuration, right? So you could target, if your minions were all named the same, you could salt.
Indeed. Is that what you meant?
Yeah, that's exactly what I meant.
Yeah, so the name matcher is the default one. We're not passing any parameters to there. The star is also just doing a name match here. It's just saying match everything. We can prefix it or postfix it depending on how we wish to match. If I wanted to match all of the 3 devices, then I guess I could do that too. But Salt has just so much more power when it comes to matches. And there's a lot of documentation on this, actually. Salt targeting. So before we look at the targeting options, let's just see the information we can pull out, and then we'll look at how we can actually use that information to target it. And let's see if I can remember the commands. So we can interact with the grains subsystem for salt by using grains dot. You can see how I use test.ping. I use command.run, and I can use grains dot blah. I believe we can run grains.ls. There we go.
Yeah.
And this is all of those key value pairs that we were talking about at the start. This is all the grain data that we can use for targeting inner state files or even just on the command line. So let's see. Will we see what kernel we've got?
Sure.
More info, please. Let's do kernel release. There we go. So we have a Linux kernel 4.9. And let's see what we've got running on our older CentOS box. Oh dear.
Oh wow, my museum kernel.
Yeah, so we can, assuming we maybe wanted to use Salt to provision some sort of, oh, I don't know why Seti's decided to, Teams. There we go.
No.
I love how I'm on Do Not Disturb mode and Teams doesn't really care. So let's just
take one for the team.
Let's just close Teams. Go away, Teams. All right. So if we wanted to say use Salt to provision kernel models or something, then that targeting might be really important. So we can use the minion name, grains, and other information to target our minions. So let's take a look at the docs. Well, I mean, this page is relatively big. There's a few different.
There's a lot there.
Yeah, when it comes to targeting, there's a lot you can do. We'll look at a couple of them just now, and then we'll try and get on to something a bit more fun. But you can do a straight up grain match. So let's run this. So this isn't going to return anything because we don't have a grain that matches, but we do have a CentOS. Ta-da! And we're just returning the SaltStack version. So the way the grain matcher works is we put the key on the left of the colon and then the value on the right of the colon. And I believe the star might work. Yeah, okay.
Yeah.
We can also do compound matchers, where we can specify, and we have to use the docs for the syntax, but I believe it's grain at CentOS. Nope. Capital G. And compound matchers allow us to use more than one match here. So I believe we can say and use another grain where kernel is low in it. Like so. So the compound matcher allows you to use grains or minion names together. A relatively painless syntax. It's not too difficult. Node groups. I don't think we'll cover node groups today, but node groups can be configured in the Salt configuration. You could like if something isn't available as a grain, like maybe you want to do something that's more rack aware, then you could configure that for node groups. What else is cool? We've not played with pillars yet. Yeah, you can do subnet and IP address matching, which is quite cool too. So if you just want to, maybe your data center is actually, maybe you don't need to go down the node groups for your rack aware stuff because you've got your network configured and the IP address is allocated on a per rack basis. I don't know. There's loads.
Yeah, the simple commands are very easy to describe, and the complexity is there as well. Like if you really need to do something special, because you can tag, like if you need to work on an arbitrary group of machines, you can tag a group of machines as a list too, right?
Yes. So let's talk about that. That's a really good point. Thank you. We've provisioned our machines with our packet metadata module.
Right.
Same one we had in VS Code. So what does that mean? Well, let's do grains.ls. Which of these is packet stuff? Facility.
Facility. Didn't pick it up.
Uh-oh. Let's do facility. Drats. Why didn't I pick it up? Let's just make sure I haven't broken the script. Yeah, that's good. Let's run. So we can, there is a sync step involved, which I thought was automated, but we can try doing this now. So we do, I'm not going to remember how to do it. Salt util sync all. There we go.
There we go.
And you can see now it's picked up that grain. So I guess that's just something I have to clean up in the automation. And it just tells it to kind of scan those expected directories for new module types. And there's loads of module types. You know, we can have states, we can have beacons, we can have different engines, loads. Okay, so let's run our grains.ls, and let's just grep. It's really not going to show up. How about get facility? Huh. What am I doing wrong?
Version of Python?
It's weird that it showed up in the sync. And it doesn't show up now, so it definitely did sync that time.
Did something, yeah.
Yeah. Normally I'd see a .pyc file here to show that it compiled. I'm going to just restart Salt.
Yeah.
Grains.get facility.
Still no happiness.
Yeah, you're letting me down, Salt. Let's check the log. I won't waste too much time on it. We don't need to work with the packet metadata today, but you know, I also don't like things not working.
That looks like metadata.
Yeah, it did hit the metadata API.
Yeah. Is an error message hiding somewhere in that, or?
I wonder if I should be worried about this. It's not my MacBook.
That's the packet metadata. So you're in a project that's shared with other people. And by default, the metadata includes all the metadata from the entirety of everyone who has access to that project.
All right, okay, cool. I was slightly worried there. I was like, I don't think we exposed any keys or tokens or anything.
No, there's no keys. Those are public. Those are publics.
Yeah, okay. It does appear, so I'm just doing something wrong, I'm sure. As well as ls, there is get. Oh, no, there's help me Salt. Salt grains commands. Oh, I got some recipes as well. So grains.ls, that's what I was thinking of. Oh, it's the same as, oh, so ls is what I was doing.
Yeah.
Items is what I want. Let's see what we have. It's under a key.
It's under a key, of course.
Okay. Phew. And there was me thinking nothing worked. So there you go. We can call packet.metadata, and if I add facility, I can't remember the stub syntax, but it's there. Okay, good. So we can use those grains if we wish to target things with commands.
Right. So we could say, for instance, do this command on all hosts in AMS1.
Yes. Yeah, I think so. Okay, so that means I need to remember how I get the sub key then. So let's try it. Salt. We're going to do a grain match. We're going to look for the packet metadata. Yeah, it's colon. It just popped into my head there, I'm sure. Yeah. Oh, no,
there we go.
now I've removed the command. Okay, so we can do a grain matcher. Let's say we do a command.run. We will run. Yeah, we'll run through. We want to match on our packet metadata on the facility AMS1. There.
There. Perfect.
Phew, it's all coming back to me. Feeling the pressure. So, what about pillars? It mostly works the same. Am I not spelling pillars right? There we go. But we don't have anything configured as a source of pillar data. But I guess we've got a few things we can do now.
You want to take a look at the list of provision machines and see if we got another, like do a salt keys and see if there's another one that's ready to pop in?
No, but we will.
Nothing?
We can quickly. Oh wait, we never got a minion too. The FreeBSD failed.
Yeah, the FreeBSD failed.
All right, but we can fix Ubuntu. I keep doing that. I keep full screening my.
Just split the screen.
All right. Okay. Yes, please. YubiKey. And let's see how far this one got. So, exact same problem with Ubuntu and CentOS. Okay, so pip uninstall. Salt go bye-bye. Eventually. Thinking about it. There we go. Yes, please. Let's do pip3 install salt.
Python pip3.
I think we just got to install it on this
Python
machine. So I don't know what's going on with Salt Bootstrap then. Maybe it's not been updated since the 3001 release. I'm not really sure. It's not important. Let's get Salt working, we'll register it, and then we'll talk about what we can do. So we can begin to add file roots. So in Salt, a file root is somewhere that has configuration that we want our Salt master to configure or consume, which allows us to provide pillar information or our state information, and we'll see how we can actually build states. I think the other thing that you wanted to cover was what if we want to install Nginx across these disparate operating systems where the package name may be different. So we can tackle that too.
Yep.
All right, so pip3 install salt. And let's grab this IP address again. La-di-da-da-da.
So do you want to talk a little bit about ZeroMQ and how Salt works behind the scenes? Or is that advanced? Or do I shut up? It is sufficiently advanced for another time.
No, let's talk about what goes on there. I think it's important. So if we talk about what happens when I run something as innocent as this command. So when I run salt with my targeting and some sort of module to run, it's important to note that the master does not communicate with any of the minions. No message is sent over a TCP stack to the minions, at least directly. What actually happens, and this really simplifies it from a security point of view as well, particularly around firewall rules, is that the only firewall rules you need to allow are your minions to speak to your master. And that's because when we issue a command here, what actually happens is the salt master writes to a 0MQ topic, and there's one per minion, I think it is. And those minions reach out to the master and subscribe to their topics. So we put the instruction onto 0MQ, the minions pick it up, they do the work, and then a message gets published back onto 0MQ, and the master consumes it to understand that the job was done. And that's it. It scales super well. Like, if you can imagine that this is a contrived example right now. We've only got a couple of minions, but as your infrastructure scales to dozens to hundreds to thousands, those messages being written to a local 0MQ and consumed downstream, it's super fast.
Yeah, it means that the network infrastructure can be simplified as well, because if you have a minion that's remote, right, it's in an edge location, it's behind a firewall, whatever, you don't need to send command, you don't need to send something directly to it. It can fetch from a more publicly reachable site.
Yeah, definitely. Yeah. So that's taken a little bit longer than I was expecting.
Is this on our C1 large ARM? I think this is on our ARM machine.
So
yeah. So there's a story behind this. Up until recently, the pip infrastructure for wheels on ARM has been lagging behind, and so in a lot of cases, we're actually compiling things right now. Yeah, whereas on a x86 machine, they would just be available.
Yes, I guess it would use a pre-compiled version, but for ARM, we have to do all that as we
have to do all that work ourselves, yeah.
All right, well, we can leave that running for now. So now we understand how the messaging works. We kind of covered what that means for a networking security point of view, at least as far as firewall rules go. Next, I guess we want to provision something, right?
Right.
we want to install some software. All right, so let's see. What do we have again? OS. Right, we got a Debian box and a CentOS box. So let's search on this is the Debian box. I don't want to pick something where the package name is the same, although I guess we could, because it's still really, even if the package names are the same, it's still using a different package manager under the hood to install it, so that's cool. Right. There's also stuff we can do by passing in, like Salt uses Jinja templating a lot, and you can use maps in Jinja to provide dynamic package names, which is quite nice. So. Yeah, okay. So they're the same, but that's fine. So what we can do, you got a suggestion there, or?
No, I think I think it's good to show off that you can run one command that'll do different things on different systems that are logically the same, but underneath the hood, they're different.
Oh yeah, definitely. I think that you're right. And before I run this, I think that would be silly of me not to kind of explain. So we could do an at search nginx with a command run, right? The problem being just me is that it's not going to work on our infrastructure which isn't Debian or Ubuntu based. Like, oh, that doesn't work. Which means we can't do apt install nginx this way. Or I could, but it would only work on a subset of my machines. And what Salt does is provide state modules, which try to abstract away most of this stuff. Like you just don't really care. And we can just use package.installed and give it the name of a package. I thought I would just check our ARM box before I run this, but it's not up yet. And package install. And behind the scenes, that's installing those packages for us on both of our machines. And the output is going to be a little bit verbose, but it's now done. So how can I convince you that that has actually happened? Let's try. Is there a package.version? I can't remember.
I think there we go. And we get slightly different versions of each of them, which is to be expected.
Well, yeah. I mean, we didn't do anything. We didn't specify anything to hidden versions or anything like that. So we're getting whatever's latest and greatest per operating system. And it turns out that CentOS is actually a few versions ahead, even though its kernel was particularly old. Yeah. So that's cool. We can also, I mean, we can trust package.version, but we can also do a command.run where we do nginx version. Oh, I think that works. Nope. There we go. And we get that same information back by directly speaking to the command line. Let's bring up this person too. Let's do some army stuff. ARM stuff. Minion. I guess we're creating this ourselves. Vim master conf master. Grab that IP address again. And restart salt minion. All right. So we run salt key. Hey.
It's not there.
There we go. Patience.
There we go.
Minion 1. Thank you. Okay, so how can let's kernel release oh, silly me. Okay. Kernel release. There we go. Not one of them the same, but I guess we expected that, right?
Yeah, we expected that.
So let's...
And I'd say, you know, the fact that we've had some hiccups because of different operating systems and different versions of things and whatnot. You know, on the one hand, having some sort of diversity in your network is useful because you get to see a bunch of new, you get to see things that you wouldn't see if they were all the same. But there's a certain hassle factor to it. And I don't, you know, for production, I very much understand why someone would have a completely homogeneous network with as few differences between the nodes as possible. But this isn't production right now. I guess it is.
Okay. I've lost my train of thought now. Oh, let's how can I check the CPU architecture? We want to see that ARM machine, right?
Yeah.
One of the Arch, maybe?
CPU Arch, maybe?
Yeah. Cool.
Hey, working.
All right, good. I feel better now. So we used the state module to do a package installation across 3 different operating systems, 2 different architectures, and 3 different kernels as well. So that's fine. So let's take a look at that list. So we looked at the pillar list earlier, but we can also just change this to grains. And we can take a look at, like, there's also, oh, why am I looking at grains? States. There we go. So state modules are the things that we can do with Salt. All right. And by do with Salt, I mean like leverage their abstractions so that we don't need to use command.run for everything. I mean, don't get me wrong. If you get Salt running in this fashion and you're just using it for ad hoc commands, like Salt command.run is fantastic, but eventually you're going to want to codify. So state modules, let's see, we can provision less encrypt certificates using Salt. We can configure Apache. Find something fun. Managing Ceph with Salt. That sounds scary.
Wow.
Yep. We can manage our cron jobs. Let's take a look at that. That'll be relatively painless. I say that now, and I bet you I break it. Anything jumping out at you?
You want to look at the file interface?
Yeah. I guess that's probably one of the most common configuration management tasks, right? Is I want to get a file onto all of my machines. So, all right, let's take a look at the cron. Now, what I like about Salt is that the examples are particularly good in all of their documentation.
Yeah.
So this will require us to write our first state file as well. Cool. So if I come to SRV Salt, and we have a directory here, I can add a states directory, and I can add my add cron state. And for doing that, we're just going to use the SLS extension, which is like a Salt state file extension, which uses YAML, which is what all the examples come in. When we looked at the extensibility of Salt earlier, and there was something called an engine, and there's also renderers. You can actually write your own renderer to take JSON or take Markdown or take just Python code or whatever and write your Salt states. I mean, I'm not sure why you're going to do that, but the extensibility is pretty cool. So there are 2 ways to write a Salt state as well. On.present, and I'll kind of cover both. Let me just type a minute. All right. So Salt allows you to, this is the explicit syntax, which is the one I tend to prefer. And that means that we just use some sort of arbitrary ID for the state, which must be unique. We then specify a module. So cron.present, we're using the cron state module, and then the function present to make sure that the cron job exists. There are others. You can see this list here. Well, if I lost it up, it's because I'm zoomed in too much. We can do absent, env present, file present. Right? So those are each of the functions that are available to us. The name is then what we actually want to execute in this state. So I can say date. We just want to write the date and output it to a file, run it as a root user, and run it, I guess that means every 5 minutes. The same syntax would be to omit the name and use that as the ID, which is also valid. I'm just not a big fan of it.
So is it every 5 minutes or on the 5th minute of the hour?
Yeah, that'll be the 5th minute of the hour. Let's take a look at the function header. Minute, hour, day, month, day, week. Yeah. Okay, so that'll be the 5th minute. If I wanted to do it every 5 minutes, it would be, was that? I can't remember. Star over 5?
I can't remember. Is it star over 5 or is it 5, 0, 5, 10, whatever?
I think star over. Let's try star over 5 and see what happens. And then we'll take a look at, we'll take a look at the cron tab and see what it generates. But let's just save that. Now, if we do a salt, so what am I doing? Oh yeah, okay. Let's take a look at our salt master configuration. There's something called a file root here.
Serve salt, yeah.
Where we can tell it how to consume our states. It's serve salt, so let's move that file. I guess it doesn't need the states. Can't remember the last time I provisioned this by hand. So let's remove states. So now we've just got this in the top level. And let's just try and see what happens. So if I say run on all machines state.sls, which is just like how I could tell Salt to run a one-off state for this. And we can tell it to run add cron. Right, and it did pick it up, but it doesn't like my syntax. And it might just be a YAML thing. There we go.
There we go.
So now both of these, all 3 of these servers have some sort of cron configured on it. So let's just pick one. We'll take a look on the CentOS machine. And if I run cron tab -e, we've got our star over 5. So every 5 minutes, it's going to execute date and write it to a file. Easy, right?
Easy.
Okay. What should we do next? You wanted to do a file, right?
Yeah, let's look at the files. No, for
let's ensure a directory exists first, and then we'll maybe dump a file inside of it. So copy in our example, we'll modify it to suit our needs. So we'll call this let's just build on this really contrived cron example, right? So let's do cron test output dir. We're going to create a new directory for this output instead of putting it under test. And we need to add our name because I don't like it being top. And we'll call this temp live stream cron test.
Okay.
And we'll configure this to write to that directory. And we'll save it. Now,
let's look at that file again. You're writing to a file in the top one. And is that a directory in the second one? Yeah, there we go.
Good catch. And then we can reprovision all of our machines except for one failed, which is, I guess, good. And what failed?
You do a make dir minus. It didn't like to create the directory because the subdirectory didn't exist.
Oh no, it failed on them all. Yeah, you're right, and it's because of the subdirectory. That's my fault. Salt has a flag for that. Make dirs. I think.
Yeah.
Try again. Nope. Let's confirm. I think it was vectors. There we go.
Majors.
I was close. Run that again. Ta-da! Success. We can run temp, live stream, cron test, and it's not run yet, but it'll run soon.
Right.
Although, because we're doing a present, it now has created this twice. And that's just because we changed the name.
Oh, sure.
So I didn't realize that we got rid of one and added one. So if we just run that again, we shouldn't end up with 3. Shouldn't. Yeah, good. Okay, what do we want to do next? So we created a directory. Let's hop over here, and we can do a file exist. No, managed. Let's do managed. There's so many different functions and modules. Okay, so let's try and break this down. So we'll give it an explicit name, and we'll call this our fake file, and we give it a name. So temp, live stream, cron test, fake. And then we can provide some sort of source. Now, the way that the file.managed works is you can specify multiple sources, and it'll stop on the first one that exists. Neither of these exist, though.
So it should fail.
Well, unless we add one that works, yeah. Okay. Shall we see it fail first?
Let's see it fail first. So.
All right. Fail, and fail.
Nothing found.
Yeah. Because we don't have a source that works, so let's come in here. Now we can do salt SLS path, which is my favorite little thing, and we'll call this fake. Now this doesn't exist still. So if we run it, we're going to see a sea of red again. But that SLS path means that it's going to use the path from where this state file is. So if I create fake, which I normally wouldn't do. Normally, let's clean this up. I feel like I'm being quite messy right now. So let's say we have our live stream state. And inside of that, we've got our init.sls, which is a convenience helper. Come into our live stream. This is our setup. And we'll have our, normally I have like a files directory. And then inside of files, I'll have fake. Hi, I am a fake file. Okay. So we made a few changes there. What we want to do now is modify this path to be files fake. And my command there is now live stream. And we don't need to put .init. I'll talk about how we address our namespaces in just a second, but I should be able to run this as is, and it works.
Yep.
And we can confirm this here with temp live stream cat fake. So really, really powerful. We also have the ability to interpolate, but let's cover the naming first. It's one of my favorite things about Salt. I actually use Salt for my dot files.
I was going to say keeping track of home directories and whatnot.
Yeah. So, and the reason I do that is because it means I can run individual parts of my state really, really easily. So if we take this as an example, we've got a live stream state that runs init.sls when it's not told otherwise. I can also add a one-off command .sls, which could just do cron test one off, which is going to do a command.run. We'll have it run who. if I run our live stream state again, there's no who. However, I can add, what did I call it? One off. I can add one off, like so, and it runs who on all of the machines. We have a full array of requisites and include helpers that we can use within Salt. So, I can do includes one off. You need a dot to indicate it's the local directory. Otherwise, I would have to do live stream dot one off. So we can do includes one off. And if I run without that, what did I get wrong? It didn't compare. Oh, hold on. Not a dictionary. This is why the documentation is handy.
It is good documentation.
It's include.
Include. Of course.
And we now have, this went up from 3 to 4. So we can see that it's now including this who output as part of the state run. And I can still individually run that one off as well. Like, I don't need to run the whole thing. And I think this is something, I'm a big fan of Ansible, but it just doesn't have that level of pick and choose what I want to be able to do ad hoc, which I really like. There's also prerequisites that require syntax. So let's say prerequisites. You can say that it has dependencies. And if we take a look at our init state, what happens with SaltStack here is it will run this file from top to bottom in order, but you can also be very explicit about the prerequisites or requisites. So we can say we actually require this step to run first, or the other options we've got are if something changes. So if a file changes, then I want to ensure that this state runs again. We can watch files. There's a whole bunch of stuff here that's really, really cool that allows you to tie all your states together. I'll kind of show one more thing, and then we'll kind of have a chat and see if you've got any ideas. So inside files, I can open fake, and I can then use this Jinja syntax, where I can reference the grains, like so. And let's run this again. And can't bake.
It didn't interpolate.
Yep. Let me see if I can remember why. Oh, yeah. So this is why I shouldn't do ad hoc stuff. We need to tell it. I think it is engine. Let's confirm that. File.managed. It's template Jinja. There we go, not engine. We just tell it that we want to template it.
And it's Jinja. It's just Jinja. It's not Jinja 2. It's not Jinja 2.
Thank you. That's better. And you can see it actually shows you the change that it made. So it removed the grains line and added our Linux line. And then I cat.
Nice.
Good. Cool. We're getting there.
That's cool. So you could see how this would be useful for. So one of the things that that you can leverage the packet metadata for is inserting SSH keys into home directories. Because the packet metadata includes SSH public keys for everyone who has access to things. So you can imagine provisioning a home directory for someone based on just their key information that you can pull from metadata.
Oh, really? I didn't know that. Okay, so shall we try and provision all of our machines with your SSH key?
Well, let's see if it's there.
So if I do curl, is it metadata.packet.net / is that right?
I think so.
Okay, so let's pipe this through JQ.
Yep. Well, Salt install JQ.
Package install. We'll do it on all of our machines.
Sure. Bring them all up.
Okay. Now, good. So we pull up a curl, pipe it to JQ, and let's just see if we can narrow this down a little bit. So, and then we'll repipe it. So that's a lot of keys there. So
yeah, it's a lot of keys because you're on a shared project.
I am on a shared project. Okay, SSH keys. So .ssh key. There we go. Now we've only got the keys. It doesn't look like there is a way to pull out individuals.
No, it doesn't.
Oh, but we can provision them all, right?
We can provision them all.
We can just trust everybody.
Sure.
Okay. So what do we need to do first?
We need to make someone a home directory.
Okay. First, I'm going to add these SSH keys to our grains first.
Oh, sure.
And yes, you're right. Let's create a home directory. And spell things correctly. Okay, so let's refresh. We don't have a refresh command. Salt util think all. Salt. Let's just run it on master star and packet metadata SSH keys. Oh, we now have that available as grain data. So you want to provision a new user, and we'll create a new. We'll use our live stream state, but we'll use a sub state. So let's call this user med. So what would we like to call this new user?
Should match. Yeah, should call it Ed.
Yeah, we've got. No, I think there is a user present module. Name Ed. Let's just confirm that. So if we go back to our state module list, user. Go down a bit. User.
Yeah, it's user.
Yep, we have access to this syntax. So we will copy it as an example, tweak as needed. So let's see, we've got name, Ed. Give you bash.
Sure.
I'll give you a home directory. Some UID. There, how's that look?
Perfect.
Okay, so let's run this. State.sls, live stream, user, and
no group exists.
yeah, we do not have a wheel group. You're getting no groups, I'm afraid. I'm removing your groups.
Okay, that's fair enough. Just as failed to create.
I wonder.
Do we have a ID match?
Good question. I was also wondering if maybe there's a minimum number of characters for a username. But I can't remember.
No, I've successfully been Ed before.
All right. I mean, I don't see 1001 user.
No, I don't either.
So let's try. Debug. Oh, it's just that. Why you fail? Why you fail? Why you fail? I mean, that's a pretty simple user present. I'm going to remove the.
You get it down to its minimum.
Right. Okay. If I remove the UID and GID, it worked.
Huh.
I'm not sure why.
Oh,
you know, I know what it is. It's a YAML thing.
Oh no! They have to be quoted because it's interpreting them as octal or something stupid.
Yeah, I know it does that with some weird numbers and format. Anyway, we're good.
We're good.
So you're now a user. So ls home ID ed. You exist. So
okay.
Next up, we want to provision SSH keys. Is that right?
Yep.
And we're going to do this at home at .ssh authorized. I think that's the correct path.
Yeah, I think so.
We need to now we need to enable template first. Ginger. Now we could do source like we did last time. However, our source is really just those keys. I believe we could just do contents. We can use YAML multi-line. I think we might get away with the.
Oh.
I think. I can't remember. Do you remember what the permissions need to be?
The directory needs to be.
I'm just making it up. I might be wrong.
700. It can't be writable.
Let's run this and see what happens.
Let's see what happens.
Let's just.
Do we get?
So we got broken. Okay, it's not liking that.
Doesn't like the multi-line.
Okay, grain, so packet, metadata. Oh, it doesn't like. Okay, that bit was fine. This is wrong. And it's because, okay, so there's, I'm going to assume I've got this understanding in my head right, but I may be wrong. There are two ways to reference grains on Salt. So we can do grains.packet metadata, which works for simple keys, but this is a complex key. So I believe what we actually need to do is grains, packet, metadata, SSH keys, like so.
Yeah. Okay.
I think.
Didn't like the.
It didn't like me not closing my syntax. So I was just missing our braces. So close. All right. It does not have. Oh, okay. So yeah, when we use the complex syntax, I think it actually breaks it up like that. I can't even remember now. I'm completely making this up. Let's see. Ah. Okay, so better. It definitely did the interpolation, but it failed because
It did the interpolation.
expected a expected a colon. So this is just my multi-line syntax, and I think the problem is this array style thing. Okay, so can I confirm what I think the problem is? Because YAML supports
This is a
array style
YAML.
syntax. Yeah, it is a YAML thing. Let's see if we can pull up a YAML validator. Are you okay for time? I should check.
Yeah, I'm good. I'm good.
All right. So what we have, and we'll copy it, is something like so. I'm not sure what that copied.
I think it copied public keys.
I'll do it this way. What? I'll type it. Thanks. So we have something like this where we're using this syntax here, and I could do this and chmod. I think this is actually mode. I got that wrong. And if we validate this,
Could not find.
oh, it is complaining. So my multi-line syntax is wrong. Maybe it needs to be indent a little bit more. Yeah.
Indented.
Yeah. So
it needs to be.
So we still have one problem here, though, which we'll see in just a second. Okay. If I go to home,
something worked.
Okay. It half worked. And the problem is we still have a
Oh, that needs to be, yeah, because that's
Yep.
just the wrong syntax.
So the good thing about the Jinja things is we have access to the entire Jinja templating library too. So I think we can do join.
Ah,
I think we can do join with a new line. That actually worked, but the indentation's wrong. You can see there's no array syntax, but
right.
Okay, so that means we need to do one more thing. And then 6, which should indent every line by 6.
Didn't like it.
Oh, it did the indent. What have I got wrong now? Maybe it's 8.
Yeah.
Success.
Hey. Wow. Love me some YAML.
Much better. Okay.
Okay, it's got blank lines in there, but I don't think that's going to matter.
Well, I'm not going to ask you if you know what your SSH key looks like, but I believe you are in this project. So why don't
I believe so.
Do you want to share your screen and see if you can connect, just to confirm?
Yeah, let me make sure that I have the right screen up. Bring up Putty, because I have a fantastic Windows machine here. And then the host name I'm connecting to is
147.75.33. .134.
And let's see if I do the right SSH key, auth. Keys.
That was minion 1. There's my cursor. I'm waiting on you.
I'm waiting on me too. It's not working.
Drat.
Let's see.
I mean, it's not terribly important, I guess. I don't even know if your SSH key is on that metadata, so that was just more for
No,
sure.
I think this is a. I think this is something else going on here. So let me. I'm switching to an off-screen computer. And what's the address again?
147.75.33.134.
Permission denied, public key.
Now, I wonder if that's because I made up the permissions on this file.
Yeah, I think you need to be 600 on that.
We can tell by taking a look at the log. So if I pull up, it's just the minion log. I don't think we got an SSH deny message. What can I look at? -XV. Yeah, I'm not really. Oh, that's the wrong machine.
No.
There we go. So authenticated user.
Could not find.
No. The pager. Oh no, that's after that. We got past that bit.
That's my IP address. That's me. I bet.
Oh, wow.
Yeah, I bet it's a file permission thing.
Yeah.
Either that or my key isn't in the system.
That's not a big deal. That would have been cool. Anyway, we've covered a lot of salt there. Is there anything we've missed, do you think? Is there any questions you've got? Is there anything?
We've covered a lot. The whole idea of using configuration on the master derived from either the master or the minion's data, right? So we covered grains and how you can interpolate grains into files. The neat thing about Salt for me is just how powerful it is for ad hoc commands, right? If you know that you, for instance, need, like we did before, like you need to have JQ on all the machines. That's a one-liner, very easy to do, very straightforward, very simple. For me, Salt is really two things. It's a very complex, very powerful, all-consuming, do everything with it system, or it's a very simple, do a couple of things very easily kind of system. I think that's a couple different sources of usefulness for it.
Yeah, definitely. I mean, I completely agree with that. So I'll, give that a big massive thumbs up. I think, when you're dealing with the ability to run ad hoc commands against all your machines or a subset of your machines is just really important. But even that, I think Salt has a lot of power even on a single machine setup. Just the ability to automate all of these things. Like, I can do Salt command.run, but putting together state files like this makes something really, really repeatable, which is really important for. I mean, so much so I use it for my dot files, as I kind of mentioned earlier. So it's just infinitely powerful and fast. I don't think we've really ever waited too long on anything happening, which is nice.
And small enough to consider on small machines. I'm actively using it on a Pi 3, which has got 1 gigabyte of memory, and it, the baseline load of what does it take to run it doesn't show up very much.
It does not have massive footprint CPU or memory wise, which is great. And super, I mean, it's pretty tweakable and configurable as well.
Yeah,
definitely. I'm just trying to think if there's anything we should cover, or if we just leave it there and maybe we'll do a second session another day.
I think we can leave it there. I mean, the key management is really something if you're bringing up a lot of machines. I think understanding like what does it take to take a machine online or offline. But yeah, I think we can leave it there. We've covered a lot of ground. That's really, really helpful, really useful.
Awesome. Well, thank you for joining me today. It's been a pleasure going through some of this stuff and chatting with you. And I hope that we can do this again soon. So thank you again.
I'm looking forward to it.
All right. Have a nice day.
Okay, take care.